Going live. I'm live. Yesterday, I was teaching, and some guys came to the door, construction guys. Like, I'm in the middle of teaching. I'm in the middle of literally teaching a live stream lesson. And a couple of guys come to the door, and they're like, "Oh, excuse us, can we do something to your room real quick?" And I'm like, "Well, what?" He's like, "Oh, we need to change out the internet box up top." And I said, "Well, will it disrupt the internet?" And he said, "Yes, possibly." I'm like, "Then no, because I'm literally using the internet to live stream." But they changed it. I don't know, whatever. I mean, they eventually came back and fixed it up, but whatever. Anyway, reminder for the yous who just joined us on online in the chat. I did put an announcement yesterday in regards to an assessment I would like to do on Friday. This is just another reminder of that for you to be ready to go. I will be ready to go, and everyone should be ready to go, and we'll be able to knock that thing out. Read that thing carefully if you haven't already. Goal for today, I would like to review the review that you guys did for me and submitted. I would like to go over these questions. Now, as I go over these questions, this is for all of you. As I go over these questions, I can answer anything I can or anything you want. I can answer about any of these questions on the review. So be sure, if you need help with one of these problems, ask the question. If you need something clarified or something along those lines, ask the question. Same thing goes for you in the chat. I'm going to keep trying to check out the chat right here on the screen. So please, by all means, ask the question. This is your time to ask the questions, the good questions, the amazing questions, the wonderful questions. After we're done with this review of this for you in the chat, I do have some multiple choice questions to go to, but we'll get there when we get there. Number one, a company sponsoring a new internet search engine wants to collect data on the ease of using it. Which is the best way to collect the data? Now, I haven't gone over your responses yet, so I don't really have a consensus. And I'm not really going to ask for a consensus right now from you guys. But let's just kind of go through this piece by piece. A company sponsoring a new internet search engine wants to collect data on the ease of using it. Which is the best way to collect the data? Now, we can eliminate some things immediately. And this is partially what you are going to have to learn. You're going to have to learn how to properly attack multiple choice questions. Now, this multiple choice question may be very straightforward, maybe very like, oh yeah, I totally get that. But I just want you to be able to eliminate things. Clearly, a census is a terrible idea in this case. You're not going to do a census of everyone in America or the world, see how they use the search engine. You're not going to do a simulation. A simulation would be ridiculous. How would you simulate somebody doing this? Tell me. What would this be if it were an observational study? What would this look like if this were an observational study? Like, think about that in real life. Nothing? Observational study, you're not interjecting yourself. Observational study, you're not manipulating anything. You're not putting a treatment on people. You are simply observing. So literally think of an observational study of somebody using like Google, and you're like observing how well they use Google or something like that. It seems ridiculous. It seems absolutely ridiculous to do something like that. Now, just for the sake of argument, I'm just going to flip this over real quick. Chapow! Oh, kapow! There we go. Kapow! You can see right there, that's my answer key. Which, by the way, for the sake of argument, copy down those letters. Copy down those letters, just the top line of letters. Now, the answer keys that I have are not always 100% accurate, and sometimes they're a little bit debatable, but I want you to at least have that. So it's not like a question of, wait a minute, Ms. Rangi, what was the answer number 5? What was the answer number 7? Just copy down now, and we'll kind of go over it together. Where's my little notepad? There we go. I'm just going to have this for myself as well. Clearly, the answer is B in this case. Let's see. B, E, C, B, C, D, C, D, A, E. Cool. I don't want to keep flipping back and forth. But in this case, sample survey. I mean, you could theoretically do an experiment here. Theoretically, you could. In fact, if I were just given, like, what's a way to collect the data, you could technically answer B or D for this one. You could. Except there's one key word in that question. There's one key word in that question that makes the answer B. What is that key word? What is the one word? the best way. Yeah. You could do an experiment, but that might cost you more money to kind of set that thing up. The best way to go about this is a sample survey. Again, there's always more than one answer, but a lot of the times they do have one way that is better than the other. Number 2, the January 2005 Gallup Youth Survey telephoned a random sample of 1,028 U.S. teens and asked these teens to name their favorite movie from 2004. Napoleon Dynamite had the highest percentage, with 8% of teens ranking it as their favorite movie. Now, I have no idea how many of you have actually seen Napoleon Dynamite. It is a terrible movie. Terrible. I was in college when that came out. I walked out. Anyway, which is true. Now, I love these. I don't know if you guys have seen these before, but these are amazing. Some of you have probably, but it's just basically which ones are true. Now, sometimes they do mess with you. Sometimes they do mess with you and they do ask which ones are false or something along those lines, but that's besides the point. This one's which one has to be true. Now, according to what we have written down, they're all true, but let's just go through them one at a time. The population of interest is all U.S. teens. The sample was taken of U.S. teens. You got to remember, samples are just a portion of that population. So yes, the first statement is true. The population of interest is just the U.S. teens. 8% is a statistic and not the actual percentage of all U.S. teens that would rank this movie as their favorite. Tell me, if 8% is a statistic, which is a true statement, what would you call the actual percentage of all U.S. teens? If 8% is referred to as a statistic, what term or what definition would you give to the actual percentage of all U.S. teens? Yeah. Well, population, there's another word that goes with it. Yes, parameter. We got to know these definitions. Technically, 8% is what they call a sample statistic. The actual percentage would be a population parameter. Please keep that in mind. And then 3, this sampling design should provide a reasonably accurate estimate of the actual percentage of all U.S. teens who would rank this movie as their favorite. Yes. There's nothing in the design that they've mentioned that would be questionable. They telephone a random sample, has to be a random sample. 1,028 looks like a large enough sample, definitely. They only asked U.S. teens, and they just asked them to name their favorite movie from 2004. It's kind of open-ended, but, you know, it has to be in that case. And then Napoleon Dynamite had 8% ranking as their favorite movie. Cool. They don't say, like, when they sampled them or how the random sample was found, but for the most part, if it's like the Gallup Youth Survey, Gallup is actually a very reputable polling situation. But if they tell you that, yeah, they performed a random sample, as long as they don't say anything that makes you question if they did it right, assume that they did it right. The answer is E. E. Let me scroll. Come on, you. Come on. There we go. Suppose your local school district decides to randomly test high school students for ADD. There are 3 high schools in the district, each with grades 9 through 12. The school board pools all of the students together and randomly samples 250 students. Is this a simple random sample? Now, if you notice, I love questions like this. 3 of them say yes and 2 of them say no. So it's not so much just answering yes or no. You have to give a proper reason behind it. And this is my caution to all of you. When you are faced with a question, especially a free response question, you have to definitely look into what they are asking. For example, there are going to be problems in the future where they ask you to construct or calculate a certain number. And then very quickly after they say calculate, they'll say calculate and interpret. And when they say that phrase interpret or something extra or explain or something along those lines, a lot of students end up skipping it and they just do the calculation or they answer yes or no or they do whatever the construction was. But if the problem does say to explain or interpret or something along those lines, you have to do it. Please don't skip it. Now, in this case, I don't know how many kids were in each school district. I have absolutely no idea. But I do know that for a simple random sample, every combination of subjects or whatever it is in the survey has to have an equal chance of being selected. It has to have an equal chance of being selected. Now, the way that C is written, or I'm sorry, the way that B is written, because each student is equally likely to be chosen, you could refer it as that. But then let's go back to A, because the students were chosen at random. That seems pretty good too. Like both of these statements look pretty good. The answer is C, because they could have chosen any 250 students from throughout the district. Even, A, B, and C, all are true statements. They are all true statements, but C is the most true. What have I been telling you about writing conclusions in statistics? From day one, what have I been telling you about writing conclusions? To make it fluffy. Yeah, to make it fluffy, give yourself a little wiggle room, that kind of thing. Statistics, unfortunately, by design, is inexact. It's inexact. And when you look at a thing like this, like someone would immediately read A and they'd be like, yep, it's got to be A. They were chosen at random. And then they don't even read the rest. Ugh. But then someone might be a little smarter and they might read B. And they're like, oh, equally likely to be chosen. Yes. C is the most true, because they would have chosen any 250 students from throughout the district. Think about the definition. A simple random sample, any combination of people are equally likely to be chosen. That most fits the definition. Some of these problems are going to make you angry, I hope. Number 4, a basketball player has a 70% free throw percentage. Which plan could be used to simulate the number of free throws she will make in her next 5 free throw attempts? Now, let's make an assumption real quick. A person shooting 70% accuracy, meaning they make 7 baskets for every 10 that they shoot, or they make 70 for every 100 or something like that. One assumption that you would have to make in this case is that the 70% is not going to change. I just missed 5 shots in a row. Okay, that's cool. You're still a 70% free throw shooter. Let's just make that assumption right now. Which plan could be used to simulate the number of free throws she'll make in the next 5 free throw attempts? Let 0 and 1 represent making the first shot. 2 and 3 represent the second shot. All the way to 8 and 9 representing the 5th shot. Generate 5 random numbers, 0 to 9 ignoring repeats. So basically, for the first shot, if you get a 0 or 1, like you could actually get a 0 and a 1, couldn't you? Yeah, that makes no sense. Screw that. 2, let 0, 1, and 2 represent missing a shot, which are 3 numbers, 30%. And then 3 to 9 represent making a shot. Generate 5 random numbers from 0 to 9 and count how many numbers are in 3 to 9. Question. Do repeats make a difference here? You're shaking your head yes. Why? Couldn't you just get like a 9, 9, 9, 9, 9 like that? Why is that a big deal here, though? Huh, interesting. Do you guys remember what I wrote? Well, you should have wrote it in your notes or something like that. I think I made a comment in your notes about repeats. Anyone have it? I made a comment about repeats. I just want to make this very clear. When we did a random simulation. And I believe I can't remember exactly what phrasing it was. You find it? Repeats are allowed if you're working with percentages. Repeats are allowed. So for part 2 right here, this is perfectly acceptable. This is acceptable. Perfectly acceptable. They don't mention anything about repeats. And since they don't mention anything about repeats, you're allowed to get a repeat, but it's okay in this instance because that 70% is not changing. You're right, though. Like if we kept getting like a 0, a 0, a 0, 0, 0, you're missing shots. Yes, you could argue that the 70% now is dropping. Or if you get like 0, whatever. But think of it this way. If I'm randomly generating 5 numbers, and I get a 0, and then a 1, and then a 2. If I don't allow repeats, then that person can never miss a shot ever again. Or for the rest of the simulation. Anyway, number 3. Let 0, 1, and 2 represent missing a shot. 3, 4, 9 represent making a shot. Generate 5 random numbers and count how many numbers, ignoring repeats. That's why 3 is wrong. The answer is B. It's only 2 that is correct. If you're dealing with percentages, repeats are perfectly acceptable. Number 5. More dogs are being diagnosed with thyroid problems than are being diagnosed in the past. A researcher identified 50 puppies with thyroid problems and kept records of their diets for several years to see if any developed thyroid problems. Cats are better. Fight me. Anyway, this is a what? Now, they identified 50 puppies with thyroid problems. And they kept record of their diet for several years. First of all, did they force certain puppies to get thyroid problems? No. Did they force the type of diet that they would have? No, they did not either. They did not force the type of diet they would have. Meaning, there's no manipulation to this problem. There's no manipulation. There's no treatment to this problem. This cannot be an experiment. This cannot be an experiment. Now, in this case, it's not a survey. In a survey, it's just basically you put out the question, they answer the question, you get it back, you analyze the results. They're keeping track of their diets for several years. This is an observational study. It's an observational study. But more specifically, there are 2 types of studies up here: prospective, retrospective. Retrospective is going to the past. Prospective is going to the future. They recorded their diets for several years. The answer is C, prospective study. Remember, the one big difference between an observational study and an experiment. In an experiment, there has to be some level of manipulation. There has to be a treatment of some sort that the experimenter did. Oh no, all my cards fell. Well, not all of them. They just kind of rainbowed out a little bit. There we go. Good job, you. Okay, number 6. Chemistry professor who teaches at a large lecture class surveys the students to attend his class about how they can make the class more interesting, hoping he can get more students to attend. This survey method suffers from. Okay, hold on a second. Don't worry about the answers. Don't worry right now. Don't worry about A, B, C, D, E. Don't worry about any of that. What's wrong with how this question is worded? Don't give me the answer for A, B, C, D, E. Don't give me any of that. Tell me what's wrong with the way this question is worded, or what's wrong with the professor's methodology, So what's the big deal? There you go. That's the inference that you really should be thinking about. He's only surveying people who show up, meaning the people who show up probably like the professor. I don't know. In a lot of college courses, they don't take attendance. You just show up when you want to. I heard of a college professor who taught in a lecture hall, and this college professor taught 300 kids. And attendance was part of the grade. So at 8 a.m., when the class began, the professor stood in the front, took a Polaroid camera, click, 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 let's move on, and then checked attendance later. It's pretty funny. Anyway, but yeah, The people who don't show up, the people who probably don't like the professor or whatever, they're not being surveyed. This survey suffers from undercoverage. It suffers from undercoverage because there is a certain proportion of the population of his class, the students who don't show up, that are not being surveyed that would greatly affect the results of the survey. They're just not even being asked in the first place. It's undercoverage. By the way, I don't know if any of you have held this opinion in the past, but I know a lot of high school students do. Sometimes you'll see like a none of the above or an all of the above or something along those lines. And you might think, that's what it's got to be. Why would they put that there? The people who make the AP test, the people who make the AP test, they hate you. They hate you with every fiber of their being, and they will make problems to purposely get you to get them wrong. They will, and they'll laugh about it while wearing their top hats. All right, number 7. Placebos are a tool for what? They are a tool for what? Now, placebos are obviously used in experiments in this case, so definitely not sampling. Placebos are a fake treatment. Placebos are a fake treatment to make you think that you have gotten the real treatment. And whether you have the placebo or you have the real treatment, you don't know that. It is for blinding. It is to blind you, stab you. I don't know, whatever. Number 8, double blinding. An experiment is important so that. Now, before I even read the answers, let me think about what double blinding is. Double blinding, there's 2 ways to blind an experiment. You could blind the subject or the participant from which treatment they are getting. That's one way of blinding. The other way of blinding is for the person doing the evaluating to not know what treatment the person got. I talked about dolphin therapy, did I? Did I? Cool. So in dolphin therapy, the treatment was whether you swam with dolphins or not. Clearly, if you are participating in this dolphin therapy, you know which treatment you got, whether you swam with dolphins or you didn't. The person evaluating your mental health in the end should not know whether or not you swam with dolphins, because that could affect how they actually evaluate you, something along those lines. Let's see. The evaluators do not know which treatment group the participants are in. Check. The participants do not know which treatment group they're in. Check. No one knows which treatment any of the participants is getting. Well, no. The person running the experiment knows who got what. The answer has to be D in this case. It has to be D. Let's scroll them down. Boom. Which of the following is not required in experimental design? Ooh. I love this. They even throw all are required in experimental design. Which one did I say was if possible or if necessary or something along those lines? Do you remember? Ooh. We didn't actually write out the notes for this. I gave you the printed out notes for this, correct? Yes. Blocking. Blocking is only to be done if the experiment warrants it. Let me give you an example. I did an experiment with reaction time. There's a website that you can go to, and it has like a stoplight, and then you start the experiment, and it goes from red, and then you have to wait for it to turn green, and then the second it turns green, you're supposed to click. That's reaction time. And then they do it a bunch of times, and they get an average. When I did that experiment, I made sure that I kept track of who the left-handed people were and who the right-handed people were. I blocked by what type of hand was your dominant hand, because it made sense in the context of the experiment. Whereas we did an experiment here with those letters. I did not block. I did not block by those letters, by your ability to memorize letters. I just randomly passed them out to all of you and then went from there. Now, yes, there were 2 different treatments. There were two different treatments. There was a treatment where you had the JFK dash, and then the other one where you just had the JF dash. That wasn't blocking. Blocking is very similar to stratified sampling, where you find a similar characteristic and then split the participants and then run the experiment. Blocking, you only do if it makes sense to do it within the experiment itself. Blocking is a if possible situation. That's why the answer is A. And then number 10, a researcher wants to compare the effect of a new type of shampoo on hair condition. Weird. The researcher believes that men and women may react to shampoo differently. Additionally, the researcher believes that the shampoo will react differently on hair that is dyed. Okay, weird. The subjects are split into 4 groups: men who dye their hair, men who do not dye their hair, women who dye their hair, women who do not dye their hair. All right. And then subjects in each group are randomly assigned to the new shampoo and the old shampoo. Interesting. This has blocking. This has blocking. They took the participants and they split them by some characteristic. First, they split them by men and women. What, they did that first, or did they just do the other one first? Oh, well, they split them into the 4 groups. Let's just say they split them by men and women, and then they took the men and split them by dyeing their hair, not dyeing their hair, the women by dyeing their hair, not dyeing their hair. By splitting them before the treatment, that is a level of blocking. They have some shared characteristic. And then they were assigned either the new shampoo or the old shampoo. There was one factor. The one factor was shampoo type. Man, if you actually map this out, this is insane. Hold on. If you actually map this out, you would have done something like maybe like men and then women and then dyed and then not and then dyed and then not and then the new shampoo and then the old shampoo and then the new shampoo and then the old shampoo and then the new shampoo and the old shampoo and the new shampoo and the old shampoo. Wow, look at that junk. Question. It's a big question. Question that's not asked up here. The answer is E, by the way, just so you know. There's one factor, shampoo type, but it's blocked by gender and whether hair is dyed. How many levels / how many treatments? How many levels / how many treatments? Because there's only one factor. Ooh, you're all afraid to answer. Yeah? No. It seems that way based on what I drew. There's just 2. There's just 2, yeah. Blocking doesn't affect the number of treatments. Blocking does not affect the number of treatments because if you think about the context of the problem, if you are a person going into this experiment, you are either going to just get the new shampoo or the old shampoo, regardless of the way this looks. Because all of, where'd my marker go? Yeah. All of this was just blocking. But in the end, it was either the new shampoo or the old shampoo. I mapped out the washing machine thing for you guys. Cool. The washing machine thing, the washing machine experiment, that had 2 different factors. The factors were dirt and type of washing machine that they went into, either the brand name or the generic one. The type of washing machine, there were 2 different types of washing machines. There were 2 levels. But then for the type of dirt, when I did it, we only did 3 types of dirt, high, medium, or low. 3 levels for dirt, 2 levels for washing machine. There were 6 treatments. For this one, there's only one factor, type of shampoo. And there's only 2 levels within that factor, old or new. That's it. There's only 2 treatments. Okay, let's scroll down. Wow. Now, a lot of these I'm going to talk a little bit more about in somewhat different detail, but we'll get there. A headline in a local newspaper announced video game playing can lead to better spatial reasoning abilities. Ooh, the article reported that a study found statistically significant differences between teams who play video games and teams who do not, with teams who play video games testing better in spatial reasoning. Do you think the headline was appropriate? Now, again, this is a subjective argument that you could do. There's 100 different ways that you could answer this, but let's just kind of break it down piece by piece. Do you believe the headline was appropriate? Video game playing can lead to better spatial reasoning abilities. Now, don't worry about the statistically significant differences because that's not what they're talking about. They're talking about the headline. You could argue, no, it's not appropriate because they're kind of making a definitive statement there. But then I guess you could argue based on the word can. I guess you could argue based on the word can. Oh, you guys are not old enough to remember Bill Clinton, are you? You remember Bill Clinton in the 1990s? He gave this interview where he was like, they were like, no, not an interview. They were like questioning him about something. And then he literally said something to the effect of, well, I guess it depends on what your definition of the word is, or something like that. Like, that's a weird statement. But look at the word can. Video game playing can lead to better spatial reasoning abilities. They're not saying that it will lead to better spatial reasoning abilities. It can lead. That's like such borderline fluffy language. Like, if I were making this, I'd be like, well, there's evidence to show that video game playing can lead to better spatial reasoning abilities. That's what I would do. That's how I would word that fluffy kind of language. Let's see what the thing said. Click. No, this is not a controlled experiment. Ooh, they went a different direction. Let's talk about this. So no determination of cause and effect can be made. Perhaps there's something about teens who play video games to make them good at video games and at spatial reasoning. Or maybe teens with good spatial reasoning enjoy video games more. They went to a completely different level. They found statistically significant differences between teens who play video games and teens who do not. Interesting. Stork spring babies. Stork spring babies. No, they don't. There is some kind of lurking variable. Some kind of lurking variable. Now, here's the thing. I don't play this kind of junk. I know other people do. Does anybody here play League of Legends? No? Cool. Do you know anybody who does play League of Legends? Cool. The people who you know play League of Legends, do they pay attention to the world tournaments? Do you know? They do? Cool. I don't know. It's so weird. I don't play League of Legends, but I have a buddy who does. He's like 26 years old. And he like just follows that crap like crazy. But he tells me that the best people in the world are like 16, 17, 18 years old. I don't get it. What the heck? See, the thing is, video game playing can lead to better spatial reasoning abilities. Maybe. They did find statistically significant differences. But is it the fact that they're playing video games, or is it the fact that they're teenagers? Storks do not bring babies. Scrolling. College student spending. A consumer group wants to see if a new education program will improve the spending habits of college students. Students in an economics class are randomly assigned to 3 different courses on spending habits. Experimental units, factors, treatments, response variable. Okay, let's go through this again. Consumer group wants to see if a new education program will improve the spending habits of college students. Students in an economics class are randomly assigned to 3 different courses on spending habits. Okay, so there's random allocation to course 1, course 2, and course 3. And then, I don't know, maybe they like have results. I just wanted to map this out for myself. Results, and then they end up comparing all 3. All right. Cross out the word experimental unit. Oh, no, you can't cross it out. You're on. Anyway, if you had the paper in front of you, you would cross out the word experimental unit because instead you would use the word subjects or participants. It's kind of not unfair, but it's kind of weird. You shouldn't be using the word experimental units when it comes to human beings. But anyway, they wanted to see if it will improve the spending habits of college students in an economic class. That's the answer. The experimental units are the students in the economics class. How many factors are there? Ooh, how many factors are there? Ooh. I'm going to ask you guys. How many factors are there? Oh, someone's going to get it. Say it again. There's just one. There's just one factor. The factor, in this case, is the type of course that they take. I was going to say class, but the type of course that they take. But that factor has how many levels? Yeah, that factor has 3 levels. Which then leads to how many treatments are there? 3. There are 3 treatments, clearly. What is the response variable? Now, this is a little more difficult. The response variable being the result. They wanted to see if it would improve their spending habits. What is the response variable? I guess you could say whether or not they improved their spending habits. Something along those lines. It's just like a brief yes or no, like yes, they did or no, they didn't. I don't know how you would actually measure that. How would you measure that? I don't know. Let me see what this thing says. The response variable. Oh, look at that. Yeah, the spending habits of the students. All right, whatever. That's weird. Anyway, I did actually read that before we go there. Number 13, good CDs. That's funny. This question. Do you guys know what a CD is? I know you know what a CD is, but do you know what a banking CD is? A banking CD. A CD is a certificate of deposit. You put a bunch of money into a CD at the bank, and you have to leave it there for like 3 or 4 years, and then it earns like much higher interest than a regular savings account. All right, whatever. That's another type of CD. I read this and I'm thinking to myself, what CD are they talking about? Are they talking about a musical CD or are they talking about a banking CD? Because he needs to give one of the executives at his company 5 good CDs. Why would he give the executive at his company a musical CD? Did anyone question that? All right, I'm just saying. Anyway. Brian's systems manager for a large company. His work, he found that about 5% he orders are bad. Let me scroll down. Is this it? There we go. Good. Here we go. Conduct a simulation for... Okay. There's a bunch of different ways that you could go about doing this. 5%. Interesting. See, if you're doing 5%, can you do 5% if you're using single digit? We have to use a random number table. Can you tell me, okay, I'm using the numbers 0 to 9. Can you split up 0 to 9 where you get 5% and 95%? You're shaking your head. No, you can't do it. You can't do that. So I'm going to have to take 2 digits at a time. Now, I don't know what this worksheet says in terms of an answer, but let me just give you what I would give. I would say something like 00 to 04 represent bad CDs, and 05 to 99 represent good CDs. Is this the only way to do it? No, this is not the only way to do it. You could assign those numbers whichever way you feel comfortable with. This is the way that I would do it. I would say, okay, these are the bad CDs. These are the good CDs. And then I need to give one of his executives companies 5 good CDs and estimate how many CDs he'll have to check to get 5 good CDs for the executive. Okay. So let's see. The trial ends when 5 good CDs are found. That's my stopping point. And then I want to know how many CDs. So I'm going to have to identify a response variable. The response variable is the number of CDs went through or that I had to go through or something along those lines. Okay, so those would be the bad ones. Those would be the good ones. The trial would end there. And then the response variable or the outcome would be the number of CDs that I had to go through. All right, let's just see what happens. Now, again, I have no idea what this worksheet actually has as an answer. Let's just go through the simulation and see what happens. Oh, looky there. There's a bad one. So good. I had to go through 6. Okay. Good, bad, and then good. I had to go through 6. and then good, 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 good. I had to go through 5. I should probably label those with a G again. I want to be consistent. Cool. Show 3 trials by clearly labeling the random number table. Specify the outcome for each trial. State your conclusion. All right. 6 plus 6 plus 5. What is that, 17? 17 divided by 3 would be 5.67. All right. So I'd say something along the lines of, based on my simulation of 3 trials, I found an average of 5.67 CDs that I would have to go through before finding 5 good ones. It appears, it seems, there's evidence to suggest that I would have to go through at least 6 CDs. I'm rounding up in this case. I would have to go through at least 6 CDs in order to get 5 good ones. Again, I'm using all 3 phrases in that case. It appears, it seems, there's evidence to suggest. Something along those lines. Fluffy language. Let me see what the worksheet said. Because I like seeing alternate answers sometimes. All right. Oh, sweet. They did the exact same thing I did. Digits 0044 bad, 0599 good. Look at pairs of digits and random numbers, determine if CDs good or bad. Continue until you get 5 good CDs. Response variables, the number of CDs. Oh, they did the exact same thing. Oh, look, the fluffy language. According to my simulation, it would take an average of 5.7 CDs to get 5 good CDs. Yeah. Silly thing, you. Let's scroll back. Click. Scroll. Bone builder. Researchers believe that a new drug called Bone Builder will help bones heal after children have a broken or a fractured bone. Did I tell you about my daughter? No? We quarantined March 13th, right? Within 2 weeks, my daughter broke her hand or broke her wrist. She fell off my son's bunk bed. That's crazy. Couldn't go to the ER because everyone's sick at the ER. Had to do a virtual meeting with the doctor. And then eventually I had to drive her up to Freehold, my little 2-year-old daughter with like a mask on and her arm kind of like this or whatever the entire time. I'd drive her up to Freehold to go see an orthopedist to get set. That was fun. Anyway, back to this. Researchers believe a new drug called Bone Builder help bones heal after children have broken or fractured a bone. The researchers believe that Bone Builder will work differently on bone breaks than on bone fractures. You guys know the difference between a break and a fracture? Do you? All right. I think he's trying to break his finger. I don't know. Anyway, even if you don't know what the difference is between a break and a fracture, that should not matter. But let's just go on here. Where was I? There you go. Because of differences in initial bone condition. Bone Builder will be used in conjunction with traditional casts to test the impact of Bone Builder on bone healing. The researcher recruits 18 children with bone breaks and 30 children with bone fractures. Design an appropriate experiment to determine if Bone Builder will help bones heal. I'm just thinking about the real life implications of this. You can't force children to have broken bones, you know? So how are you getting these kids with broken bones all in one particular location, unless you're like dealing with it across the country? For the sake of time, let me show you this. Click, scroll. Here is one example as to how they could do this particular experiment. Now, first of all, if you notice, they took the children and they blocked them at the very beginning. They blocked them by some shared characteristic. They blocked them by the type of bone issue they're having, whether it be a break or whether it be a fracture. Then, within that block, again, blocking very similar to stratified sampling, within that block, they randomly assigned them to one of 2 treatments, either the Bone Builder or a placebo in this case. Now, they're giving them a placebo. I mean, that kind of sounds weird. Like, why would you give a kid with a broken bone a fake treatment? But keep in mind, they're still getting the regular cast. So they're still getting their arms or whatever they broke. They're getting them set. So keep that in mind. They're not just leaving these children out to die. Now, if you notice, there's an uneven number within the blocks. That's okay. It's perfectly acceptable. You're not always going to get an even number between the two blocks. But then when they randomly assigned them, they did try to make them as even as possible within the treatments. And then they compared bone condition. Blocking is employed since breaks and fractures have different initial bone condition. This experiment can be double-blind if the patients and bone evaluators don't know whether or not the patient was given bone builder. Yes, since the patient was not aware as to what treatment they received, then they are blinded to that fact. But then the person evaluating the healing levels of the bones is blinded as to, okay, this kid, I have no idea what treatment they got, but let me evaluate them and then give the results. That person is blinded as well. This could, yeah, definitely double blind. Did they ask if it was to do that kind of thing? They just said, design an appropriate experiment to determine if it will help heal bones. Yeah. That was just an extra little thing right there. They explained why they did blocking. They explained that it was double blind because they don't know whether or not the patient was given the bone builder. There was a player for some college basketball team. I want to say it was Louisville. They were in the NCAA tournament, and the guy went up for like a jump shot, and then he broke his leg. Anybody remember that? You do remember that? Well, why am I bringing that up? Yeah, that's called a compound fracture. Compound fracture is when it actually breaks through the skin. Isn't that weird? Anyway, you should watch the video. I'm not going to show you the video. Back to here. Scrolling down. Finally, military funding. College group is investigating student opinions about funding of the military. They phoned a random sample of students at a college, asking each person one of these questions, randomly chosen. Do you think that funding of the military should be increased so that the United States can better protect its citizens? Or do you think that funding of the military should be increased? Which question do you expect will elicit greater support for increased military funding? Explain, and what kind of bias is this? This one's pretty straightforward. Do you think that funding the military should be increased so that the United States can better protect its citizens? Yeah, that one most likely will elicit greater support for increased funding. What kind of bias is this? This is just straight up response bias. This is response bias. Response bias is anything within the experimental design, specifically the wording of this question, that elicited some kind of an emotional response. This is response bias. Let me show you a good example of response bias, actually. I had a different class who, I gotta find this one. I think I know where this one is. I had a class who they were trying to put together questions for me. And I immediately told this kid, like, of the, whatchamacallit, the issue that I had. Not that one. Here we go. Classwork, survey questions. There we go. And I told him that what he had written was like just absolute like response bias. There we go. Let me open this one. And here we go. I'm just going to read it to you because I don't want to show you his name, but I'll just read it to you. The question that he put was, do you think teachers should give less work because students do have lives other than school? Yeah, that is definitely response bias right there. What are you doing, kid? Oh, goodness gracious. Okay. Let me flip this back over. Now, I am going to go over these questions with the other half of the class tomorrow, obviously. But if you guys have any additional questions on this particular review, please make sure that you are messaging me separately if need be. For now, for the time that we have left, I do have a multiple choice challenge for you. It's just not a challenge. It's going to be graded or anything. It's just like you kind of like challenging yourself to see what you can do. So what I'm going to ask, take out the whiteboards from underneath your desk. You have the whiteboards with the marker, with the eraser. Make sure you have all three. If you don't have all three, you can check one of the other desks over here on the side of the room. But basically, all you're going to be doing for me is you're going to be writing the letter the letter to the that you believe it to be. Yeah. Now, obviously, I know how multiple choice things typically work. You look around, you see who else has like an answer. You kind of like, okay, I have no idea, so let me just write down the answer to the person next to me or something like that. No, you write down what you think it is correct. Now, for those of you in the chat, unfortunately, obviously, if you type in your response, you can type in your response if you want. That's up to you. But this is just mainly like a challenge for the people writing on the whiteboards. If you want to join in on the chat, please, by all means, you can. And we'll kind of talk how this thing goes. Now, I've shown this maybe once or so, but I do have this box of flashcards, which are amazing. And these are perfect examples as to the type of multiple choice questions you will be seeing on the AP test. A couple of reminders. First of all, how long is the AP test supposed to be for statistics? There? 3 hours. It's split up an hour and a half and an hour and a half for multiple choice and free response. Multiple choice. You have an hour and a half to get done 40 multiple choice questions. If you do the math on that, that is roughly 2 minutes, 15 seconds per problem. 2 minutes, 15 seconds per problem. Some of these multiple choice questions you will be able to get through super quick. Some of these multiple choice questions might take you a few extra several minutes, maybe 5 minutes, who knows? But you need to be able to manage your time appropriately. I haven't proctored the AP statistics test because they don't allow the teacher to proctor their own students. But I've talked to teachers afterwards, the teachers who proctored the test, and they have told me that, yeah, when I told them there were 10 minutes left on the multiple choice section, at least half of them popped their heads up and just were like wide-eyed. And I'm like, yeah, I know. I've been training them all year and they still ignored my advice. Don't ignore my advice when it comes to dealing with these multiple choice questions, because you got to give yourself a chance. Give yourself a chance. They do not take points off if you guess and get it wrong. They do for the AP test. SAT, maybe that's differently for the SAT, but for the AP test, they don't take points off for guessing and getting it wrong. They don't. Let's see this question. Zoom out, zoom out, zoom out. There we go. Of course, I'll read this one. Each of the 30 Major League Baseball teams carries a 40-team roster. A sample of 60 players, 5% of all 1,200 players, is to be randomly selected to undergo drug tests. To do this, each team is instructed to put their 40 names in a hat and randomly draw 2 names. Now, they did say randomly draw, which means the implication is that the hat was shook. Will this method result in a simple random sample of 1,200 baseball players? I'm going to give you a minute or so to kind of read through those responses and write down what you believe the answer to be. And when you do write it down, please make it large so I can see it from across the room. But don't hold it up until I say so. If you haven't picked an answer, make sure you're writing one down. Hold them up. Let me see what you got. Let me see what you got. Let me see what you got. Ooh, interesting. Okay. Keep holding up. Keep holding up. Keep holding up. So all of you chose A except for you 3 who chose different answers. Okay, put them down. Let's say that there are 3, no, not 3, yeah, 3 players who play for the New York Yankees. New York Yankees have a 40-team roster. Actually, let me speak this into the mic. The New York Yankees have a 40-team roster, or 40-player roster, I should say. And all 40 players put their names in a hat. They want a sample of 60, okay, but they want to do 2 per team. So they want 2 Yankees, 2 Dodgers, 2 Mets, 2 Phillies, 2 Giants, etc. And that will eventually add up to 60 players. So if there are 3 players on the Yankees, and the first one gets selected, and then the second one gets selected, does that third one still have a chance of being selected? He does not. He does not. Once 2 players from the Yankees are selected, boom, no other Yankee could ever be selected ever again. Is it possible for all 40 players from the Yankees to be selected? Nope. It's not possible. You're only going to get 2 per team. You're only going to get 2 per team. Now, what's interesting is the 3 of you had 3 different answers. Let's see what happens. Chapow. Answer's E. One of you had E. Who had E? You had E. There he is. You did? Oh, I'm sorry. I'm so sorry. I thought that's why I was trying to look at all of them all once. I thought you had written down A. I apologize. Now, simple random sample. Every possible group, every possible combination has an equally likely chance to be selected. But it's not true here. For example, this is procedure to be impossible for all the Cubs to be together in the final sample. The procedure is an example of stratified sampling, where they split everybody up to their individual teams, and they took a little bit from the Yankees, a little bit from the Cubs, a little bit from the Giants, a little bit from the Mets, etc. But stratified sampling does not result in a simple random sample. Haha, multiple choice questions. I love them. Let's do this one. Advantage or advantages to using surveys as opposed to experiments are that. I know the wording is terrible, but they do that. See what you think. I'll give you about a minute. So for those of you who are in the live stream on Friday, y'all met my daughter very briefly. My wife sent me this picture because apparently her Halloween costume showed up. She's a unicorn. I don't know. That's amazing. Anyway, let me see your answers. I do see that. Sorry. So all of you chose A except for you 2. Okay, let's see what happens. So since all of you chose A and D, and a couple of you chose D, then I'm all assuming that you believe statement number 1 was true. Surveys are generally cheaper to conduct. Yeah, they typically are cheaper. With experiments, you get a lot more that goes into it. And then you all believe that 3 was wrong. Surveys are generally not subject to bias. Oh, that's clearly a false statement. 3 is definitely a false statement. Clearly, it could be subject to bias. So it comes down to your argument about the second statement. It is generally easier to conclude cause and effect from surveys. Unfortunately, you cannot do cause and effect from surveys. You can only do cause and effect from well-designed experiments. You can only do it from well-designed experiments. Generally cheaper, quicker to conduct. However, surveys are subject to bias, and it's very difficult to conclude cause and effect from surveys. Very difficult. Smoking causes cancer. It clearly does. You can see all these people that have smoked for 20 years, and they develop cancer. Yeah, but that was a survey. You're going to have to do something else in order to prove. So this question. A company wishes to survey what people think about a new product. it plans to market. They decide to randomly sample from their customer database, as this includes phone numbers and addresses. This procedure is an example of what type of sampling? I'll give you about 5 more seconds. And then you got to make a choice. Remember, don't leave multiple choice questions blank. Don't leave them blank. Give yourself a chance to get them right. You never know. If I just use educated guessing on the last 5 problems, perhaps I have a chance of getting a few of them correct. You never know. Hold them up. Let me see. Ooh, good. Okay, keep them held up. Keep them held up. Hold on. I got an A. I got a bunch of B's. I got a few C's scattered around. I got a D over here, and I got an E question mark. This is great. All right, put them down. This is perfect. People reading this would immediately think, okay, they randomly sample from the customer database, as includes phone numbers and addresses. Okay, so they randomly sampled. There's nothing crazy to it. A lot of people would automatically think simple random. However, and a lot of you did figure this out, or some of you did figure this out. Who were they surveying? Their own database, their own customer database. But if you reread the first statement, a company wishes to survey what people think about a new product. They want to know what people think about a new product, but they're only surveying existing customers. Ooh, that's clearly a level of bias, but that's not what the question is asking. The question is asking what type of sampling. It's convenience. They're only choosing individuals that are easy to reach. The wording of the question is going to mess with a lot of people. Because if you're trying to spend 2 minutes per problem and you just kind of read that, there's one bit of phrasing that's going to mess you up. Because the AP people who make the test, they hate you. Let's try one more. Yeah, because I got a couple minutes. I want to make sure I get a good one here. Nope, not that one. Ooh, interesting. Okay, let's do this one. Last question for today. Sampling error occurs. And then you give me the answer. When does sampling error occur? Write down an answer. I'm going to ask for it in a moment. All right, let me see. Ooh, interesting. Bunch of different answers. Looks like mostly E's and then a few A's and C's mixed in. Okay. Sampling error is a definition. Sampling error is a definition that I gave you. Sampling error is not a mistake. Sampling error is something that naturally happens. Look back in your notes. I said sampling error or sampling variation. Different samples give different sample statistics. Put those things back underneath. Make sure you're double checking your notes about sampling error if that is the case. If you have any questions, please make sure you are emailing me in preparation for Friday. I'm going to sign off. Thank you, too.